Here with another physics video. Today we're going to be looking at infrared and the temperature of the Earth. So we're going to be looking at this question: why is the Earth heating up? So this was a picture on the front of The Economist, which is a magazine that was out on September 2019, and it shows how the temperature of the Earth has changed over the last 150-200 years by showing different colours. So darker blue shows where it's colder, to reds, which is warmer. So you can see there's been some variation over the last 150 years or so. The blues in the 1850s, then quite the dark blues in the 1900s. There was a little blip by the looks of it, just before 1950, where it was a little bit warmer. And then in the last 20 years, 30 years, you can see just how many reds and oranges and dark reds there were, showing that the temperature of the Earth has just been really, really warm compared to normal over this last 20 years, this recent times. But why is the Earth heating up? So that's what we're going to look at in today's lesson. So let's start by asking this question then. So why is the Earth warm at all in the first place? So here's the sun. Here's the Earth, and the sun, as we know, produces infrared. Here's the infrared travelling at the speed of light from the sun, getting to the Earth. And if the amount of infrared absorbed is more than the Earth emits, then the Earth will heat up and the temperature will go up. Why doesn't the Earth just carry on heating up then? So as it heats up, it starts to emit infrared as well. And as the Earth gets hotter, it emits more infrared. And when that infrared that it emits is the same as the amount that it absorbs, then the temperature will be constant. Right, so that's why the Earth heats up. Let's have a look at what the greenhouse effect is. So it would be a certain temperature, but without some gases around the Earth, then it would be a little bit cooler than it is now. So around the Earth, there are these greenhouse gases, and the main greenhouse gases are carbon dioxide, methane, and water vapour. And the reason they're called greenhouse gases is because, just the same as how a greenhouse works, infrared goes in through the glass of a greenhouse, it hits the surface of the ground gets hot, that starts to emit infrared radiation. Some of it goes back through the window, but a lot of it gets reflected back off the window and back into the greenhouse and keeps the greenhouse warm. So it's the same kind of idea. So some of the infrared comes through the greenhouse gases from the sun. The Earth gets hotter, emits and re-radiates infrared back towards the greenhouse gases. Some of them go through, some of them are absorbed by the greenhouse gases, and some of them then get emitted to space. But then some of them also get re-radiated back towards the Earth, and then that means that the Earth gets warmer. So as the Earth gets warmer, then eventually more infrared is radiated from the Earth, and then the temperature of the Earth will stay then at a constant temperature, but warmer than it was before. And that's basically what the greenhouse effect is. So the temperature increases because more infrared is being re-radiated from those greenhouse gases back towards the Earth. But the greenhouse effect can lead to global warming if those greenhouse gases increase. So here you can see we've got a larger layer of greenhouse gases, and if there are more greenhouse gases, then what will happen is that the infrared will carry on coming through. It will warm up the Earth. The Earth will re-radiate the infrared back towards space. It will be absorbed by the greenhouse gases, and then the greenhouse gases will emit some out to space, but will emit even more back towards the Earth, which will increase the Earth's temperature even more. So the Earth's temperature will rise if there are more greenhouse gases around the Earth. And that's basically what's happened over the last 100 years, especially. The greenhouse gases have increased, and you can see here in particular we're looking at carbon dioxide here. So the blue line is the carbon dioxide that has been emitted over the last 1,000 years or so in parts per million, so ppm of carbon dioxide there. So on the left hand side you can see the scale there, and you can see how that line was pretty stable from 1000 AD all the way through to about 1900, and then it rose steadily after 1900 to where we are now and increased a large amount. And what's really interesting is the fluctuation in temperature, which is shown by the red line. And you can see that we went through these sort of 100-year cycles or so, or 50-year cycles of temperature change, going up and down and up and down and up and down, sometimes further up, sometimes further down, but always kind of around about the same temperature there. You can see sort of around about 13.7, 13.8 degrees, which is shown on the right hand scale. But then over the last 100 years the temperature has also shot up, and you can see how it's linked to the shooting up of the parts per million carbon dioxide that we've got as well. So this is what you should be able to do by the end of this lesson then. You should be able to describe how the Earth gets warm in the first place. You should be able to describe what the greenhouse effect is and how this leads to global warming, and you should be able to explain the link between rising carbon dioxide levels and the rising temperatures. So why is the Earth heating up? Well, it's down to the greenhouse effect, and the increasing greenhouse gases increases the temperature of the Earth, which we call global warming, and that's all down to the fact that we're using more fossil fuels for electricity and other things, which is causing more carbon dioxide. Okay, so that's this video over on infrared and the temperature of the Earth. I've been Mr. Baker, and I will see you next time. Thanks very much.